Okay, in this presentation we're going to look at, essentially it's a quick one really. Essentially what we're going to do here is use the law of total variance here. Okay, now I won't get into a derivation of it, but this is a very useful law, a very useful rule for dealing with probability events. Essentially the variance of y can be written as the expectation of the conditional variance of y dependent on x. Okay, so you see that in internal part there, variance of y dependent on x, plus the variance of the expected value of y dependent, conditional on x as well. So it's the expected value of the variance of the conditional variance plus the variance of the conditional expectation. Okay, now I won't get into a derivation of it. So essentially, what we're doing here is taking it as a statement of fact. Okay, now. So what we're going to do here is look at these two variables here. The random variable x and y are related as follows. X is conditional on y, y equals y, with specified as follows. So it has a mean of 2y and a variance of y squared. Okay? So it's essentially the parameters of x, the values of x are conditional on the values of y. But we do know what the distribution of y is. Y is a normal distribution with mean 200 and variance 100. Okay, so essentially what we have to do here first off really is just the question is derive the unconditional variance of x, var x. Okay, so just rewriting this formula, essentially I'm just going to flip x and y. Actually, do you know what? I have it down here. So I'm just going to flip the positions of x and y here because we're dealing in terms of x conditional on y. So we start off with, we just re-express that formula there as follows. Okay. So you can just check x where y is and y where x was and so on. Okay. So the expected value of the variance of x conditional on y is given as follows. It's essentially y squared. Okay, so the expected value of the variance of x given y is essentially the expected value of y squared. Now the variance of the expected value of x conditional on y, there we are. So it's essentially that's what gives us it there, 2y. Okay, so the expected value is 2y. So straightforward enough really. So the expected value of y squared plus the variance of 2y. Okay, that's how we get here. Now, so I'm going to break it up into two parts. So the expected value of y squared can be written as the variance of y, which we know, plus the expected value of y to be squared. Okay, which we also know. So that is equal to 100 plus 200 squared. Okay, so that's where this part here comes from. Okay, now variance, I'll just go down here a little bit further. Variance of 2y is simply 4 times, or 2 squared, the variance of y. Okay, so that's 4 times 100. So overall, that's 100 plus 200 squared. Okay, remember that square is inside the bracket, so it just refers to the 200 only. Plus 4 times 100, that gives us 40,500. Okay, so this bit you should watch out for. If you know, just actually this bit like sort of might trick you, but remember this expression here. This is just a reworking of the standard expression for the variance of a random variable, just rearranging it. Yeah, so that's it. It's a short enough one, really. The key thing here was using the law of total variance in a worked example. All right, we'll leave it there.